Okay, so here's this guide video. So train A runs back and forth on an east-west section of railroad track. Train A's velocity, measured in meters per minute, is given by a differentiable function v of A, where t is measured in minutes. Selected values for v, I'm saying of A, I should say sub A. Selected values for v sub A of t are given in the table above. Okay, now remember guys, when they tell you that something is differentiable, you need to know that that is implying smooth and continuous. Okay, because a function is not differentiable at sharp corners, so that's why it's smooth. Okay, so first we're going to find the average acceleration of train A over the interval 2 to 8. Oh, and also, I'm just going to give myself a little, let's see, measured in, all right, so so it's basically like a horizontal thing. All right, so west, east. Okay. All right, so average acceleration. So acceleration would be the rate of change of velocity. So I could just do the average rate of change of velocity on the interval 2 to 8. So I need to do v sub 8, v sub A of 8, v sub A of 2, all over 8 minus 2, and this is no calculator. So this is negative 120 minus 100 all over 6, negative 220 over 6, negative 110 over 3 meters per minute per minute. And a more sophisticated way of saying that, guys, is meters per minute squared, but the top is fine. Okay. So that right there is 1 point. Okay. That's 1 point right there. Okay, now part B. Part B. Do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t with t between 5 and 8? Give a reason for your answer. Okay, so I'm not trying to prove that the derivative, so I'm not trying to prove that the derivative of v takes on a certain value. If that were the case, I would be using the mean value theorem. I'm trying to prove that the value of v sub A takes on a certain value, so that would be the intermediate value theorem. So let's see. Is v sub A continuous on the closed interval 5 to 8? Yes, because the function is differentiable, which means it's continuous. Okay, so I've got continuity I need to use the intermediate value theorem. Now, is this value negative 100, is it between the outputs at 5 and 8? Yes, it is. Okay, so I could use the intermediate value theorem to prove that train A's velocity takes on that value. All right, so I'm going to do it like this. All right, so I'll be like this. I'll be like v sub A of 8. No, I'll say 5 first, I guess. V sub A of 5 is equal to 40. V sub, sorry, I'm like thinking about something else as I'm writing. V sub A of 8 equals negative 120. All right. and negative 100 is an intermediate value. And guys, what they say, and I like this, they say 40 is less than negative 100 is less than negative 120. Okay, so that's what they say in their reasoning, and I like that. But this is how I taught it the first time, is an intermediate value, so that's why I put it there. Okay, you could say this. You could say this. Alrighty, since V sub A of t is differentiable, it is continuous on the closed interval 5 to 8. Oh, see, so continuity on the closed interval, that's what we need for the intermediate value theorem. Therefore, by the intermediate value theorem, there is a time t with 5 less than t less than 8 for which V sub A of t equals negative 100. Now this part here, there is a time t with this. I just kind of, at some time t with that, so I just like repeated right there. Okay, alrighty, so now that is 2 points. That's 2 points right there. All right, now C. Okay, so this is part C. Okay, at time t equals 2, train A's position is 300 meters east of the origin station, and the train is moving to the east. Okay, so it's right and it's moving right. So if you go, let me actually go like this. All right, so this is west, this is east. Let's say that this is the origin station. Okay, so at time t equals 2, train A's position is 300 meters east, and then it's still moving east. Write an expression involving an integral that gives the position of train A in meters from the origin station at time t equals 12, and then use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at time t equals 12. Okay, so I'll be like this. I'll say, or let me just go like this. All right, so I'll say x sub A of t. This is going to be equal to, or actually, let me try. I don't like the sub stuff. So I'll just say to my reader, I'll say, let x of t equal the position of train A. Okay, and then I can just say x of t equals x of, they're giving us at time t equals 2, they're giving the position. So it's going to be x of 2 plus the integral from 2 to t. And then in here will be x prime of w dw. So x of t is equal to x of 2 is 300 plus the integral from 2 to t And then this, the derivative is v sub a of w dw. Okay, so I wrote that integral expression. Now I need to, they want me to use a trapezoidal sum, okay, with 3 subintervals indicated in the table. Oh, actually, I'm not done. So this is x of t equals, or x of 12 equals 300 plus the integral from 2 to 12 v sub a of w dw. All right, so this is what I'm going to need to use the trapezoidal sum for right here. All righty. Okay, so 0, all right. This is going to be 2, 5, 8, and then 12. Oh boy, that negative is going to give me trouble. Okay, so 140. 140, negative 120, negative 150. Okay, 0, 0, 2, 100, 5, 40, 8, negative 120. Okay, so I'll connect all of these. Okay, now I'm only doing a trapezoidal sum from 2 to 12. All right, and with a trapezoid, guys, what if they're rectangles, this is the base if it's a rectangle, but that's not the base, this is the height. That's the height of the first trapezoid. Okay, so the delta x's are the heights. All right, that's the height. And then this is the first base, this is the second base. Okay, so that's the first trapezoid. They're on their side. All right, so the trapezoid is like this. So this is base 1, base 2, or vice versa, it doesn't matter. And then that's the height. The trapezoids are on their side. Oh, yikes. Okay, and then the trapezoid from 5 to 8. How am I going to do that? Will that work? I think I can do it. I think, okay. So then from 5 to 8, so that's like the height of the trapezoid. This would be base 1, that would be base 2. And then how would this work? To make a trapezoid. Is that a trapezoid? 1/2. No, that's a parallelogram. Sorry, guys. Shoot. I know how to do it without the picture. The picture is giving me trouble. The picture is giving me trouble because I want to do like a triangle here and then like a triangle there. Okay. Shoot. I'm probably just not seeing it. All right, I'm not going to start the video over because this is a guide video. I think it's probably better to just not use, because this would be the height. I mean, I guess this is a trapezoid. I guess 1/2 base 1 plus base 2. All right, let me see if this actually works. So it would be 1/2 base 1 plus base 2 times the height. I guess that would work. Base 1, base 2. Yeah, I guess that this does work. I guess that is technically a trapezoid. Because a parallelogram is a type of trapezoid. I don't like it though. Okay, and then, all right, and then for this last one, this is the height, and then like base 1, base 2. All right, so there's this trapezoid. All right, so this one here is actually a parallelogram, but a parallelogram is a type of trapezoid. It's a trapezoid where the bases are equal length. So, okay, so for this first trapezoid here, so it's 1/2, base 1 is 100, plus base 2 is 40, and then the height for that one is 3. Okay, so this trapezoid is, if I distribute the half, go ahead of me, guys, okay? So this is 50 plus 20 times 3. That's 70 times 3 is 210. All right, so 210 is that area. Okay, then the area for this next one is 1/2. Base 1 is 40, plus base 2 is negative 120, and then this height is 3. All right, so I'm distributing the half, so this is 20 minus 60 times 3. So that's negative 40 times 3, so negative 120. So this is negative 120, is that area, the area of that. Okay, and then this trapezoid is 1/2. Base 1 is negative 120. Base 2 is negative 150. And then the height of that is 5, I think. No, it's 4. It's 4, the height of that. Okay, so then this is negative 60 minus 75. You could do this in a different way, guys. Negative 60 minus 75 times 4. All right. I already did that, actually. Do I get... What did I get? I got negative 135 times 4. Negative 135 times 4. 12, 13, 14. So negative 540. Is that what I got before? I did. Okay, so that's negative 540. Okay, so the position is going to be approximately 300. Okay, 300 is right there. And then we're estimating this integral like this. So plus 210 minus 120 minus 540. Okay, and then when you do all of that, I got negative 150 meters. Okay, so x of 12 is about negative 150 meters. So that means that the position at time 12 is 150 meters to the west of the origin station because it's negative. The 3 subintervals indicated by the table to approximate the position of the train at time t equals 12. Okay, they didn't say, like, explain it in the context of the problem, but I guess I'll say, so this is 150 meters west of origin station. Oh boy, okay. Yeah, guys, to be honest, like I just do the picture for teaching, for demonstration purposes. When I'll show you my, like before. Well, actually, let me go back up here. So just from experience, I know that like the first trapezoid is going to have, so this is going to, this difference is going to be the height. And then this is going to be base 1, this is going to be base 2. And then I know for the second trapezoid, this difference is the height. This is base 1, this is base 2. And then the last trapezoid, this difference is the height. This is base 1, this is base 2. Okay, so that's how I did it just without the picture, and then the picture just kind of threw me off because of the parallelogram in the middle. Okay, now let me do this last part. Okay, this is a really hard problem, by the way. Okay, D. A second train, train B, travels north from the origin station. So we've got, and it's always good if you could like visualize things, guys. Okay, so there's the origin station. All right, this is west, this is east, that's north, that's south. All right, a second train, train B, travels from the origin station. At time t, the velocity of train B is given by this right there. At time t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at time t equals 2. Guys, let me say that train B is like here. Let me say that train A is here. I gotta speed it up because class is gonna start soon. And so I'm gonna be like this. I'm gonna be like, let X equal distance of train A from origin station. Let Y equal distance of train B. All right, so that'll be X, that'll be Y. And then the distance between them right here, like that, I'll call that Z. So this is basically, guys, like a related rates like sort of problem. So what we know is that find the rate in meters per minute at which the distance between dA and dB is changing at time. Okay, so we want dz dt. All right, we know dx dt at t equals 2. Guys, we actually know that from this. We know it's 100. What else do we know? At time t equals 2, the train is 400 meters north of the station. Okay, so we also know at t equals 2, y is 400. Oh, and we know from part C that at t equals 2, x is 300. At t equals 2, x is 300. And also, guys, Pythagorean theorem, okay, this is like a 3, 4, 5 right triangle. So 300, 400, that'd be 500. So also at t equals 2, z equals 500. All right, so guys, if I set up Pythagorean theorem, I got x squared plus y squared equals z squared. All right, and this is hard. And I take the derivative of everything. So 2x x prime plus 2y y prime equals 2z z prime. Don't use z if you think it's too complicated with the twos. So this is what I want. So I've got 2x x prime, 2y y prime, 2z. All right, that's what I want to solve for, is z prime. So in for x, I put 300. In for x prime, I put 100. That's this right here. In for y, I can put 400. In for y prime. Guys, you can get y prime from this. Okay, this is actually y prime right there. I'll let you think about y. And then you plug 2 in for this, and I did it earlier and I'm running out of time. When I did it earlier, I got 125. So if you plug 2 into here, you'll get 125. You get 125. 125. And then you plug in for z and you get 500. Or not plug in for z. If you plug z in there and you get 500. And then you've just got to solve for z prime. The bell's going to ring, guys, and I already did this. So z prime is 160, and you should do that for yourself, but it's 160 meters per minute. Alrighty, guys, that was wicked hard, but you can do it. You can definitely pick up some points there.